And thanks for some great talks. Bit of a hard act to follow. This talk is much more about, I guess, nuts and bolts of something that you might do when analysing data projects. So I've sort of been involved in a lot of data projects. I'll just go through a bit of background first, and I'll sort of say why gnumaker. It's not really about R in a sense, and how to use it, and then I'll concentrate on the package to help you use it. And it's a possible tool that you might find helpful. And I guess my background is that most of my working life has been as a stats consultant. So I've done a lot of analysis, and I've had to do the same things over and over again. I've used a lot of software, R almost exclusively for the last 20 years. But not only, because I work the same as the previous speaker, I work in medical statistics, so I still use SAS and Stata a bit as well, and certainly my collaborators do. But I've also, since the 90s, I've used gnumaker and version control. So when I saw version control introduced into RStudio all those years ago, I thought, that's great. People might start using it, but I guess in Australia, some of us have been using it for a long time before Git, of course. And of course, we've also used literate programming like Sweave and much more recently R Markdown, which are just fantastic. But I guess I could ask you, if I have time, if any of these, if you've ever sort of experienced any of these things. People will come along and say, "Oh, I've got a really simple question for you. If you're a consultant, it's only take 5 minutes, and I won't ever see you again." Anyone familiar with that? Well, sometimes they turn into massive projects, and so if you're not careful, you might forget when they come back in 6 months what you did. And you could use the R Markdown approach, or the R Markdown first approach, of course. We have several data points that need deleting, and of course, can we rerun the analysis? So here, I guess I'm preaching to the converted, but if you're using a Markdown or some other tool, then it's easier. Although we've seen a great way to use Word today, and I guess the other one that I used to get quite a bit is the journal's got back to us, but it's not actually the last paper. It's the previous one that we did all those years ago. And so sometimes it's really hard to track back what you did. And so I just say that reproducibility is sometimes very hard. And no matter what you say, you really need to look after it. And as I say, I'm preaching to the converted. So in these situations, documentation, as we saw in the last talk, is really important. Standardised systems can help, and there's also some good computing tools. And I guess I'll say one last word on reproducibility, because I'm sure everyone's aware of it in this room because you're at this talk. But there's a lot of scientists, not just statisticians, that see reproducibility as a crisis. And so there's a Nature article, Monya Baker, no relation, of course, in Nature that interviewed 1,500 scientists, and more than half of them said that there's a significant crisis in reproducibility, not just at the data analysis stage, and also of all of those, only about 30% said that the lab that they were working in was doing something about it. So I really like the dry approach, not just because I was born in the desert and raised in the desert. This is a creek bed. It's very unusual. There's a bit of water in there if you can see it. My apologies if you've seen this slide before, but it rains once every 30 years or so, and so the creek had some water in for a change. But I really like the dry approach for the don't repeat yourself, and we could take a wet approach, which I'm sure you've probably all seen. Waste everyone's time and so on. So I always like to think about that. And I guess what the previous speaker said about the workflow of a data analysis cycle is the first thing we've got to plan and start documenting everything. They might, in the medical situation, this might be code books. We need to organise things. We then carry out results. And certainly in the projects that some of them I've been involved in, these take a lot of R files, not just one Markdown file, but I'm sure different experiences are out there. And then when you carry out the results, you communicate the results, and you go through this process quite a few times. And actually, Scott Long in his book on data analysis workflow for Stata gives some really good guidelines, but I prefer to use tools where I can, and I think gnumaker is one of those. So this is the sort of project that I might be involved with. It might have all sorts of directories, including admin and documentation, and data, but I'll do some work in the analysis, reading and cleaning data reports. All of them have makefiles, and there'll be an overall makefile. I can reproduce or repeat any of the work that needs to be repeated, and so I'd sort of say, well, why use gnumaker? It's a pretty old tool, and I guess Carl Broman sums it up for me, and he thinks that really Sweave or a Markdown or whatever is not maybe the most important thing, but gnumaker is, and I would argue that sort of along with Git and Markdown and alternatives, of course, then really these tools are really important for reproducibility. And I guess the reason is if you start trying to repeat stuff manually, the whole reason Make was written in the first place is because someone was recoding stuff and not ever getting the right answer. He realised that they weren't rerunning everything, so they were leaving stuff out. So it automates the process. And so I guess it's a de facto standard. It aids reproducibility. It doesn't change much. I would say there's other great things out there like Drake and all sorts of scones, the Python stuff. There's just masses of stuff, but a lot of that changes a lot. It doesn't always work. It breaks. Make is a bit the opposite. It just never seems to change. So that's why I like it. I can just concentrate on the stats, not sort of trying to fix up my make files. It also documents the workflow because you can see what should be run with what, and you can use it with Git because you can just keep the source files. Anything that you can produce, then you don't need to keep it on Git. You can always reproduce them, or you might keep the odd report because then you've got a sort of something there nice and hard and fast that you can sort of compare things to, and you can of course automate it. So I guess. For those people that haven't seen Make before, it is pretty old-fashioned in the sense that we have a target file here. We can have some dependency files. So they might be things like an R file or a Markdown file, or a SAS file or a Stata file, Perl file, and data files, and we run some commands. And so every time that needs to be rerun again. Make knows what to do, and if all these dependency files haven't changed, then the target file doesn't get updated. So it's pretty straightforward. Got to be a bit careful if you're copying stuff off the web because Make expects tabs, so it's pretty old-fashioned in that sense. So if we had, for instance, an R file, so we've got a target file. It could be a PDF. Well, say a notebook file, but we've got here just a text file. Then we've got a read file. R commands might be cleaning some data. We've got a Stata data set. Then if it needs to be run, it'll run this command, the batch command down the bottom there, and basically if it doesn't need to be run, it tells you it's up to date. So this is a good way to sort of rerun things. You probably gathered that. So in complex projects, I don't think you just have one R file or one. I mean, I have seen it. I have worked with people that have their 550-line SAS or SPSS file that they run every time that they do something, but that's not how most of us work. So you can have a lot of smaller files, and this is where it comes into its own. I guess the only problem with Make is it doesn't have automatic rules. It does for things like C and C++, that it was developed for, all sorts of things, Fortran, but for stats packages, it doesn't have them, but they're easy enough to define. So you just use something like a % here as a wildcard, and the dollar less than sign is really the first dependency, and so that'll just sort of run that for you if you just put in a rule with the same sort of pattern there. And so these are the sort of rules that you could use. You're going to produce a report from your markdown file. You might produce plots from your R file and so on. As long as you've got the appropriate rules, then it'll work. And so I have written a whole lot of rules, and they're up on GitHub, and so you can get them, and they sort of come with the gnumaker package anyway. All you have to do is include the rules. And so if you look at that file, and you might say, well, if you already know what that means, that's no problem. It's pretty easy to work. So you could usually read them from the bottom up. So we've included the rules. We read the data, and that depends on those two files, the R file and the data file. And then we'll run some analyses, and that depends on reading, of course, the data first, and then the R file and so on, and then we'll produce some reports. And so you might think, well, do I really have to learn another language? And so you don't want to do that, so you can just basically use this package. And so part of the package will be it'll produce makefiles for you, and it'll also produce a dependency graph. So the thing about a makefile is it needs to be, the relationships between your files need to be a DAG, an acyclic graph, and so a directed graph, and so it'll also produce that and check that it is. So that basically all you really need to do is install the package, load it as a library, and then you can specify the dependencies here. So the targets are just basically from previously. You've got the read.r file and your data file, and so you've got a target that we're just calling read here. The gnumaker will sort that out for you. The same with the linear model and then the reports. And so it'll decide by default. It'll decide that reports PDF, but you can easily change that, and that if you're running an R file, it'll just produce text output. And so at the top of the file there, we had two targets, and so in this case we've got rep1 and rep2. We might have two different reports. It's just for argument's sake, and so they're both PDFs. But we can change that around, so we could have documents and PDFs. So we can see that we can build this up, and it can be quite large, and basically we can also put in comments, because I think you need to comment anything, even old-fashioned makefiles. And so that's about all I'll show you. There's a whole lot of other options that you can use, and it produces this object gm1, which is a GNU Makefile object, S3 object, that you can then print. You can write it to a file, you can plot it. And so basically it just produces by default the text that would go into a Makefile. It also tells you that it's a DAG, and it's got 10 edges with 10 nodes. And if we want to write it, we can just write it using the write Makefile function, and basically this is what it looks like. So then you can run it. You can have it. You can set it up in RStudio or Emacs, whatever you use, and off you go. And if you plot it out, you'll get the DAG. And so you can see how this works. So these are your source files, your R files, and your Markdown files, your data file, and these are generated files here. And so you can always put these files that are green in your GitHub or Git repository, GitLab, whatever you use, Bitbucket, and then you can reproduce these using the Makefile. You also should put the Makefile in the GitHub repository, and we can also get rules. So on the types of files. So the types of files, I'll just quickly skip over this, I think, but basically these are the types of files it handles. Happy to take feedback, which I occasionally get, and include more. And I guess if we think about, say, a particular file like a Markdown file, RMD, then these are the types of files at the moment that it can produce, including PowerPoint, IO slides, Beamer PDFs, the same as what you do in RStudio, but you just can specify it on the command line. So by default, it's a HTML, so you might have that RMD file plus a few dependencies there. And I guess also you could produce IO slides or Beamer, so that's the way this was produced. And you can also produce a syntax file. Just by the rules will run the Markdown file however that needs to be run. And you can actually also, I haven't included it yet, but you can also you can see this in the paper that's coming out in JSS, but you can also change environmental variables so that you can use different sort of outputs that aren't actually in the sort of package that is set up. And so there's all sorts of things you can do. You can set target-specific variables to multiple targets if you know about Make already. You can do those sort of things. You can use a mixture of Sweave and knitr instead of just choosing one. There's all sorts of things you can do. So I will just say quickly in summary that I really think that I know there's a lot of great alternatives, but three really useful things that help data analysis. And we've seen a couple more today, I think, but GNU, Make, Git, and Markdown. And I really think R is something that helps reproducible data analysis as well, because you can easily make functions and packages. I know you can do that in Stata and SAS, but I don't think it's as easy, but maybe I'm biased. And it's really useful to use Make if you have a good modular workflow. So a lot of small files doing separate tasks, you don't have to rerun them again. You don't even have to think about them. You can forget all about them once they're done. And I know that there's some alternative build systems, but I don't think, well, at the moment they're not as stable. So I'll just say that. And I guess the GNU Maker package will get you started. And I guess the future, well, I'll leave it at that. I think that's enough. Thank you.
Thank you, Peter. Now I know how to say GNU. I was using latex for quite some time before someone told me it's not latex, it's LaTeX. Just one question. How did you create this fancy slide position indicator in the header of your slides? I was going to ask the same.
LaTeX. Sorry, it's latex. It's just Beamer. It's so in Markdown, at the top of in the YAML file, you can put in different. You can put in pre-docs and post whatever processing text files, and so it's out of my old Beamer slides. But I've sort of given up on Beamer, and I use Markdown. Share this, please. I'll put it up on GitHub so that you can get the source.
Do we have another question?
Yes, so Make is great, true, but if you are on Windows, GNU Make on Windows, I don't know, running implementation, easy to install.
So if you use Windows, then if you install RTools, the latest version, RTools seems to, it used to have really old versions of everything, but these days it seems to be fantastic, and it seems to have the latest version of Make, so GNU Make. So you can easily install it from just by installing the latest version of RTools. And in Mac OS you can install, if you use Homebrew, then you can install gmake, because the Mac one is really the one that's sort of ancient if you just install the standard sort of tools.
Okay, so you find the Make, your package finds the Make, or do I have to configure it?
Yeah, so you can. So if you use RStudio, you can configure it. If you use Emacs, and some of us still use a combination of both, then you can. If you sort of it will find it if you install it, because if you install RTools and you put it in your path, then it will, whatever you run will find it. So put RTools at the start of your path, like the bin file, the bin directory.
We have one last question up the top.
Yes, I was having this issue. You showed the plot for the Makefile. That's in one directory, but is it possible if I have a root directory when there's several subdirectories, like in the dry workflow package, that I can have a DAG of all the sub-make files that are constituting the project?
That's a big question, bigger than you might think. So yes, it is. The DAG will get out of hand, I suspect, but it is possible, and it sort of starts to depend how seriously you want to start using make, whether you want to use recursive make or non-recursive make, and it gets really complicated. But yes, it is possible. But I'm happy to talk about that later or have a look at it offline.